Assalamu alaikum. Hello everyone. Today I am going to discuss with you some problems from static chapter 2 8.2. Here I try to bring the problems from the chapter which are both important and cover all the problems, all types of problems. Okay, that means if you can understand these problems, you can solve any type of problem from this chapter. These problems are very important also. First problem is, on an inclined plane a 10 kg weight force is kept in static by applying of 2 kg weight force along the plane and a horizontal force. If the angle of inclination of the plane to the ground is sine inverse 3 by 5, then we have to find the magnitude of the horizontal force. Here three forces are acting in this at this point C, and theta is sine inverse 3 by 5. So if we take resultant along the force P, we along the force 2, first we get 2 cos 0 plus r cos 90 and 10 cos minus 90 plus theta. Here this is minus 90, here we bring minus sign because we have to take the angle from this direction. Okay, from this direction 90 degree plus theta, so that's why we take minus sign here, minus 90 plus theta. Okay, and p cos minus sin theta. So between my cos ratio the minus becomes plus, so we get 2 minus 10 sin theta plus p cos theta, and the after calculation we get the value of p is 5 kg weight. Okay, now second problem. Here our second problem, if the forces 3p, 4p and 5p acting at a point are in equilibrium, then we have to prove that the first two forces are mutually perpendicular to each other. Three concurrent forces are acting along the different lines are in equilibrium, and then the magnitude of the resultant of any two forces will be equal to the other force but opposite in direction, and the angle between the forces 3p and 4p is theta. Third force is 5p, so 5p square is equal to 3p square plus 4p square, 2 times plus 2 times 3p times 4p cos theta. So here if we add this 2 and we get 24p square cos theta will be 0, and then theta is 90 degree. That means the first two forces are mutually perpendicular to each other. Now after that, this problem, here a string of length a is attached to a vertical wall and a point on the surface of a uniform sphere or radius. If the weight of the sphere is W, then we have to show that the tension of the string is T is equal to 2 by root 3 W. If we draw a figure according to the question, we get a picture like this. Here three forces W, R, T are in equilibrium. So according to, by applying Lamis law, we get T divided by sine R and W, the sine angle between R and W by sine R and T, that means the angle between R and T, and R by sine T and W, that means angle between T and W. Taking first and second ratios, we get T by sine pi by 2 and W by sine pi minus theta. Okay, so T is equal to W by sine theta, that means AB by AO, so WAO by AB. and we have to substitute this AB by AO square minus OB square root over AO square minus OB square. So and we substitute this AO by 2 I say, and we get by simplifying we get W times 2 I say divided by root 3. So tension is 2 by root 3 W. Okay, so tension of the string is 2 by root 3 W. Next, there is another problem we have here. If three forces PQ are in equilibrium by acting respectively along the perpendiculars on the sides BC, CA, B drawn from an interior point of the triangle, we have to show that PQR is equal P is to Q is to R is equal to sin A is to sin B is to sin C. Also P is to Q is to R is equal to S to B is to C. By applying Lamis law, we get P by sin QR, sin angle between Q and R, and Q by sin angle between P and R by sin angle between P and Q. In quadrilateral DOEC, ODC plus OEC is equal to pi, so DOE is equal to pi minus C, so P, the angle between P and Q is pi minus C. Similarly, angle between Q and R is pi minus A, angle between P and R is pi minus B. Okay. So from equation 1 we get P by sin A, Q by sin B, R by sin C. So P is to Q is to R is equal to sin A is to sin B is to sin C. And by applying this formula, A by sin A, B by sin B, C by sin C is equal to 1 by K, we get sin A is equal to AK, sin B is equal to BK, sin C is equal to CK. Then we get P by A, Q by B, R by C. That means P is to Q is to R is equal to A is to B is to C. Next, here two forces P and Q acting parallel to the base and length of an inclined plane respectively and singly support a weight on the plane. We have to prove that W is equal to PQ divided by root over P square minus Q square. Here three forces. First, this P is acting along the base, and here Q is acting along this parallel to this plane. Okay. For first case, by applying Lamis law, we get sin R by sin W and P. R by sin W and P. Here we have to notice that the angle between these two, pi by 2, that means 90 degree, this is also 90 degree, and here this is alpha because these are similar angle. Okay, so since this is alpha, this will be alpha also. So since this is 90 degree, so this angle will be 180 degree minus 90 degree plus alpha. That means 180 minus 90 minus alpha, that means 90 minus alpha. That's how it becomes pi by 2 minus alpha, this angle. Okay, similarly this is pi by 2, this is alpha, that's why this is also alpha, and here this is also pi by 2 minus alpha. But by the explanation is this. So by applying Lamis law from first figure, we get R by this angle, W by this angle, R by this angle. So P by sin alpha we get, and R by W by cos alpha we get. So W square by P square will be cot square alpha. And also applying the Lamis law in second picture, we get Q by sin alpha, W by sin pi by 2. So W square by Q square is equal to cosec square alpha. And by subtracting 1 from 2, we get cosec square alpha minus cot square alpha is equal to W square by Q square minus W square by P square. So W1 is equal to W square times P square minus Q square by P square Q square. So W is equal to PQ divided by root over P square minus Q square. That's it. I hope these problems will help you to understand this topic covered in this chapter easily. And please, if you have any problems in any specific problem, let me know. I will try to bring the solution of that problem more easily for you. And subscribe my channel. This will motivate me work for you. Thank you everyone. Assalamu alaikum.